Assalamualaikum. Today we are going to conduct our second lab, and the topic of the lab is compound logic, and title of the lab is to design the layout of the static CMOS basic gate using the compound implementation in Microwind software, and after that we reproduce the results using the Microwind simulator. The main objective of our lab is to design the universal gate using the compound logic, and the lab CLOs and the PLOs that we will achieve at the end of the lab are CLO 1, 2 and the 3. CLO 1 is basically mapped on PLO 3 and CLO 2 is basically mapped on the PLO 5, and the last CLO 3 is mapped on the PLO 10. CLO 1 and 2 are achieved during the in-lab task, and the CLO3 will be achieved after the completion of the lab, or it's in the form of the lab report. So let's move toward the lab introduction. So we are going to implement our basic universal gates using the compound implementation. The brief introduction and the practice of the compound implementation is already given to you in the theory class. So here I am going to give you a brief definition of the compound logic. Basically, the compound gate performing a more complex logic function in a very single state of the logic, and it is formed or combined with the help of the series or the parallel switches. The goal of our lab is to design the CMOS NAND and NOR gate, and then design the layout using our software tool. After that, we are going to verify it with the help of the simulation. It's in terms of the timing diagram, and after completing these three tasks, we are going to find out gate delay, area, power and the current analysis. So the first basic universal gate is the NAND gate. NAND gate is the opposite of our AND gate. Like, this is the function of our AND gate, and the NAND gate represent that it's not of the AND gate. The symbolical representation of our NAND gate is like this. If we are going to work on the two input NAND gate, then we have two inputs A and B, and at the end we will get the output in the form of F. So here is a bubble that indicates that it's not the AND gate, it's basically a NAND gate. So it means that the result of the AND gate will be inverted after passing through this bubble. The truth table of the NAND gate is represented here, in which it's very clear that the output will be 0 when both the inputs of the NAND gate are at logic level 1 or at high level. So the rest of the inputs give the output 1. How it will be implemented in the form of the compound logic, as we have already studied in a theory, is that the compound logic represent in the form of the series or the parallel combination of the switches. So here is our PMOS switches, and these are the NMOS switches. So when we are talking about the dot product in the form of the CMOS technology, then PMOS are going to be in the form of parallel, and the NMOS is going to be in the form of series. So these are the combined form of our NAND gate. So here is a dot. It means the PMOS are connected in the form of parallel combination. So here it's very clear that these two PMOSes are in the form of parallel, and their drains are connected with the VDD. So in case of the dot, the NMOS are connected in the form of series. So here is the NMOS, these are connected in the form of the series. So here it's serial compound logic diagram. The other basic universal gate is the NOR gate. NOR gate, in which and the NOR gate is the opposite or the inverted form of our OR gate. So it's the our equation of the OR gate, and it's the equation of our NOR gate. So if we are working on the two input NOR gate, then we have two inputs A and B, and at the end we will get the output in the form of F. This bubble also indicate that this result of the OR gate is going to be inverted. So OR gate says that if there is any input is going to be 1, the output will be 1. So if we invert this scenario, then we will get that if there is both the inputs are going to be 0 or at low level, low logic, then our output will be 1, and for the rest of the combination of the inputs, the output will remain 0. So if we are going to our CMOS technology, then we will see that if there is a sign of addition or a plus sign, then it indicates that our PMOSes are going to be connected in the series and the NMOSes are going to be connected in the parallelogram. So we can say that it's basically the opposite of dot product. So what we will do in the form of two inputs combined with the dot is totally opposite with the two inputs combined with the plus. So here you can see that the PMOSes are going to be connected in the form of series, and then MOSes are going to be connected in the form of the parallel combination. So it's the basic overview of our basic universal gates, NAND and the NOR. The basic function, truth table, and the CMOS technology diagram is also given. So what you are supposed to do is first to design the layout of two input NAND gate, and this will be done with the help of 0.5 micrometer CMOS technology. Use the CMOS generator to generate the layout of the NMOS and the PMOS, and after that you are going to be show the results using the Microwind simulator. So these same steps are going to be applied on the 3 input NOR gate, not the 2 input. It's going to be changed into the 3 input NOR gate. So we have get the practice of the 2 input and the 3 inputs. The same CMOS technology length is available, and the same you are going to generate the generators out layout of NMOS and the PMOS, and then you will show the result by using the Microwind simulator. So here these are your tasks, and you are supposed to be complete these tasks within the during the lab session and submit it almost for 15 minutes to upload the task. So the evaluation procedure is the same. After completing your in-lab task, every student is supposed to send me the Microwind file, and the time duration to send me the file is about 15 minutes after ending your online lab session. This time is very enough for you because the task is very easy, and you will complete it before your lab duration, and this time is well enough to upload your task on the C online. And to achieve the CLO3, as you have already practiced about how to achieve the CLO in the form of the lab reports, at the end of the lab you are supposed to submit a lab report on your CA online portal, and the time duration for the lab report is basically before the next lab. So this is all about today's session. If you have any question, you can ask it very freely. Thank you so much for the session.